Hello, hello, hello. Good morning, good evening, wherever you are. My name is Mark Borstein. I am the CTO of Tremolo Security and co-author of Kubernetes and Enterprise Guide. We're talking about third edition. And my co-host, Scott Sorovich, and co-author, unfortunately, won't be able to join us today. But I did want to get this lab out because this is a popular one, and it's also the most complicated one, and it's going to take us the longest to get through. So, wanted to try and get through this entire chapter, which will wrap up all the labs by the end of the year. So, that said, let's talk a little bit about where we are. We're in chapter 19, that's the last chapter of the book, and this is where we build a developer portal. So all sorts of great technology in there. We got Vault for secrets management, Argo CD for GitOps, Open Unison for authentication automation, Harbor as a image repository, GitLab, lots of things to integrate. And if you're not new to the book, if you've been here a while, you're going to hear some familiar names in there. That's because we're trying to build on what we've done in previous chapters. So last time, and let me go ahead and bring my screen up. So last time we set up our control plane. So we're going to have 3 Talos clusters. Last week we set up the first one, or I guess 2 weeks ago before KubeCon, we set up the first one. This is the big one. This has got, I think, 16 gigs of memory. And then we also went ahead and trusted our enterprise CA cert. So, going back in time, or going back to the fact we're an enterprise book, most enterprises internally, you've got a CA certificate that you've got to deal with. So we went ahead and integrated that. Since then, I have set up 2 more Talos clusters. These are single node clusters. So just to make my life easy. So we've got dev and we've got production. So when I say dev and production, the control plane is going to have all of our orchestration. Dev is going to have our dev tenants. Prod is going to have prod tenants, right? Makes sense. So we are going to kick this off by first going to go ahead and deploy, or at least start the deployment. We're going to have a lot of downtime because a lot of these steps take like 10, 15 minutes to run. So we'll dive into some of the code while it's running. So that being said, let's get started with our deployment. So our clusters are running. Now, before you get started, depending on how you're running these VMs, I will tell you snapshots are your friend. We're deploying a lot of stuff, things go wrong. And like I'll show you here, I've got snapshots here, the various steps along the way. And then when I want to start over, instead of trying to turn down everything and then start again, I like to go ahead and just roll back and start fresh. So yeah. So and if you're out there in TV land, please say hi, ask questions, love questions, and we're gonna go ahead and get this party started. So I am on page 595 of the book. And let's see here. So where am I? I want to hide this because I don't need to see that. See this? Okay, great. So I'm in book 3, and we're going to go ahead and so the first step is to run the Helm upgrade on kube control, get nodes. I'm in the control plane. Now I've already run this command. So it's probably just going to come back and say, yeah, we're in good shape. Nothing's really changed. Now this is of course complaining about my my whatchamacallit, my privilege, because Talos by default runs in unprivileged mode. I've already patched Nginx's namespace here to be able to run privileged ports. I'm going to go ahead and run the port. So it says no change, right? So I've already done that. All right, so our control plane. Now we didn't include this in the original or in the automation because ingress can get really funny depending on how you do it. So like, let's say you decide you wanted to fire up an EKS cluster to do this, or you want to fire up something on like a droplet on DigitalOcean, or pick your favorite way to do VMs. And how you do that ingress really changes. Maybe you want to do this in a little bit more real world setting where you have multiple nodes per cluster, and you're running something like middle LB or some other bare metal. So ingress can get a little weird. So that for that reason we kept that as the automation. That's one of the reasons we did that. Okay, so we're going to initialize Pulumi. Now, if you are not familiar with Pulumi, Pulumi is an infrastructure as code system. And like I said, we're going to focus first on getting everything running, and then while it's running, we're going to talk a little bit about Pulumi. So I created a directory. So I'm in here in book v3, and you can see in my sidebar here in code all of the graphics. This is where I stick all the graphics for all of these live streams. So I'm going to create a chat directory called chapter 19. Right? Okay. And the first thing I'm going to do is I'm going to create a virtual environment. Now I'm on my Mac. I use Homebrew Python because I find it to be less temperamental than the one that comes with Apple. So I'm going to go ahead and initialize that. Python 3 -mvn. Right? Yep. So what this does is this creates a sandbox environment for Python. Python, you've got to pull in all the dependencies at runtime. And if you're an old Windows dev like me, you remember DLL hell, trying to get all these dependencies to not overlap on each other. The way you fix that and it's not just Python that does this, is you create a sandbox with all of them for what you're doing, so that way they don't tread on each other. So I've created it, and then I'm going to activate it. So I now am in my own little Python world. And so next up is I need to download my dependencies. So let's go ahead and do that. So pip3, I probably already have it. Yeah, so I had already checked out, obviously, the source code from this. So I'm going to go ahead and just run it. So this is installing everything into my environment. And excellent. All right, so now the next step is I need to initialize my Pulumi environment. Pulumi's got a really great online service that is free for some level. I don't remember what it is, but we really didn't want you to have to sign up for anything. So the examples here all use a local file to store all of your to store your stack, to store your state. That obviously is a terrible idea in a production environment. Out of the box, Pulumi supports all sorts of stuff, including their own. So feel free to use that, but just to keep it simple, we're going to do it with a local file. So Pulumi login. All right, so I now have my own local environment. And what I'm going to do is I'm going to go into a different window here, and I believe I'm in the right environment. So I went into my checked out source code, and I'm going to make an archive of the Git code and put it into my local directory, because we need to make changes to the Pulumi config for it to work correctly. And so I don't like making that directly into a Git archive or into a Git directory. So Git archive, and I probably already have this saved. Yeah, so format tar, head, and then this goes into where I'm doing my work. So what that does, that pulls out all the Git related subdirectories. So this is now a fresh, clean um, set of directories. Now, imagine I just did that with code with an archive that had secrets in it, even encrypted secrets. Um, that's bad. Like that's a big reason why I'm always talking about keeping anything secret in Git is a terrible idea because I just now lost control of it. But that's a different conversation. And we already covered that chapter. So we're back here, and I now have this chapter 19.tar. So let's go ahead and expand it. XVF chapter 19. Nope. No. At some point, uh, code installed this like autocomplete for my terminal, and I don't like it. I can't figure out how to get rid of it. All right, and then RM chapter 19.tar. Okay. All right. So I am now on page 597. Now, this is the change that we need to make. We go into the Pulumi directory. There's this file called pulumi.yaml. Hey, Kafka, bonjour, my friend. Always glad to see you have joined, one of our regulars, Kafka, joining us from, I'm assuming you're joining us from France with, speaking French. But yeah, so let's go ahead and make an update here. So I need to update this runtime options virtual environment. So I need to update this to be where I am, right? So this is where I created my virtual environment. All right. And then we're going to initialize our stack. So this creates all the subdirectories. So now we can actually use the Pulumi command and do all sorts of interesting things. So Pulumi, stack, init, book v3 platform. Okay, good. Oh, I got to go into the Pulumi directory. Ah, all right. So we're initialized. Um, Now, this is where we get to the initial deployment, and I have a quote here, an ancient proverb of the cloud native Sith. Eventual consistency is a lie. Um, I don't know if you noticed, but I'm a kind of a Star Wars fan. Um, and so there's a great personality out on the socials called Cloud Native Yoda that puts together all sorts of funny memes about Kubernetes. And I like to joke, there's a cloud native, if there's a cloud native Jedi, there's a cloud native Sith, right? And everything about Kubernetes, consistency and eventual consistency. You shouldn't have to do things in an imperial way, but that is of course not true. And how do I know it's not true? Because webhooks are not retried. Yeah, so we're going to have to run our Pulumi in multiple steps. So we can't just say, okay, Pulumi, here's all the initial information, hit a button, go, everything deploys. We can't do that. So we're going to do it piecemeal. We're going to run 3 or 4 different times to get everything up and going. So the first thing we got to do is initialize our environment, and we need to be able to do that here. So I created a script that lets us set the initial stuff. Now, I already have a DNS wildcard for idp-cp.tremolo.dev. I don't need this, thank you. And then I also have wildcard set up for dev and prod to point to my my dev and prod clusters. So that's already set up. The default username for Harbor is going to be admin. And so all we really need to do is say, okay, where's Kubernetes? Where's my kube at? So if I do kctx admin at control plane, That's the context. When I originally wrote this chapter, it was kubadmin. I've seen the light in the way of Talos, and I've almost completely given up on using kubadmin for anything. All right, so that's that. So let's go ahead and set this configuration. So you can copy and paste, or actually, I'm going to be smart about this. Oops, scripts, Pulumi initialize. So that sets our initial configuration. How many programming languages does Pulumi support? We'll talk a little bit more about this. The very short answer is lots. Probably every language you use. So we got that. And then we can see what the values look like. So if I do Pulumi config, so that's all the configuration options. Not a lot, but that drives like 99% of what we need to do. So now we're going to do Pulumi up. Yes. And away we go, as the Joker would say. So this is going to run, this is going to take about 10, maybe 15 minutes. Excuse me, depending on how good your hardware is, how fast it is. But yeah, so this is going to take a minute. So now that this is going, I'm just throwing out my tissues here. We can talk a little bit more about what Pulumi is and infrastructure as code. So I knew Pulumi. Yes, Pulumi has been around. It isn't as popular as Terraform, which kind of makes me sad a little. I quite liked working with Pulumi. This was my first experience working with it. It definitely has some quirks that we're going to talk about, and we're going to spend some time talking about. But Pulumi. So let's talk a little bit about infrastructure as code. When we talk about infrastructure as code outside of Kubernetes context, we're talking about tools that let us deploy our infrastructure. So if you've run the other labs in the book and you've gotten to this point, you're looking at scripts, bash scripts, right? So like here's Kubernetes and Enterprise Guide, and like I think like chapter 6 is where we first start working on Open Unison. And we've got this bash script in here. Right, and this bash script does everything, right? It runs all the commands. And in a relatively controlled environment, this is fine. It has some shortcomings though, because like here we're doing some search and replaces to change variables for your host name. We're doing all sorts of stuff to make it work. But again, it's controlled, right? Like you probably wouldn't want to use this script to deploy Open Unison for a production environment. Lord knows I don't. And then also, you don't have any drift management. You don't have any centralization of the config. So infrastructure as code goes beyond this to say, hey, we're going to create a standard way for you to deploy infrastructure, to interact with the various APIs. Because, if you're going to deploy an infrastructure, we've been talking about Kubernetes for the last 18 chapters and how many weeks, 20 something weeks, and lab episodes. But there's more to life than Kubernetes, which might get the gods angry at me. But there's your cloud infrastructure, right? What's Kubernetes running on? Is it running on VMware? Is it running in a public cloud? So there are APIs available to deploy that. We're deploying all of our applications onto Kubernetes, but that's not necessarily going to be true. You might be deploying it into VMs. You might be deploying it outside of Kubernetes. And then each of these systems have their own APIs, right? And so it's not just the Kubernetes API, it's all these different APIs that you have to interact with. And so infrastructure as code gives you a way to be able to approach that in a more consistent fashion. Um, and so there are basically two kinds of infrastructure as code. There are those that maintain state and those that don't. So those that don't, probably the most famous is, outside Bash scripts is going to be Pulumi, or I'm sorry, not Pulumi, Ansible. Please forgive me. Uh, Ansible is a venerable veteran of the IAC world, and I've once heard it called a SSH loop for Bash scripts, and it's not the worst description. I mean, it's more than that, and it gives you more. But what's important about Ansible is it doesn't maintain any type of internal state. So when you run an Ansible playbook, um, you're just running through the steps. There's nothing that says, well, this is what the state should be. This is what the state is, and we're going to change that delta. That doesn't exist in Ansible. State managed systems and one of the things that you lose with that is you can't manage drift. So if you deploy, so I'll give you an example. I've got customers where I deploy Open Unison with Ansible into VMs because Kubernetes isn't available for some reason. And if somebody goes in and makes a change on those servers, I end up overwriting them because there's no drift management in Ansible. There's nothing to say, well, this was the difference and this is what it's just straight through, this is what we're going to do. And that's great. And it's you can do really fantastic things with it. But sometimes what you want to be able to do is you want to be able to track what's changed. And so you need some kind of state management to do that. In Kubernetes, that state management is your etcd server, right? So we're going to talk about GitOps and the difference between what's in Git and what's in your cluster and the drift there. But other infrastructure as code tools like Pulumi, like Terraform, I would probably say Puppet was probably the first one to do this, though somebody will probably prove me wrong on that one. Or Chef. Chef was another really popular one once upon a time before Kubernetes took over the world. Maintains an internal state database so that way it can manage the drift. And when there's drift, it brings you back to where it's supposed to be. So Pulumi is that second one where we have that internal state management. Here we're maintaining that state in a file. Had we connected it to Pulumi's cloud, that's where the state would be. We could put it into an S3 bucket, all sorts of stuff. So now the next question is, okay, how are you actually going to implement your code, the code part of infrastructure as code? So Terraform has its own language. It's a domain-specific language. Pulumi takes a different tack. Pulumi says, we're going to let you write it in almost any language you want. So they've got bindings for, gosh, you think of it, they probably have it. And I'm just pulling up I'm trying to think of one that's a little more complicated, but not too complicated. Well, I guess I'll go with Open Unison. And so we went with Python. And the reason why we went with Python, shout out to Kat Morgan, aka user bin Kat. She introduced me to Pulumi and the Cargo project, which is a awesome project that she started to be able to use KubeVirt as your VM platform and all sorts of automation on top of that. And she got me involved in it and let me contribute an Open Unison module. I said, oh, wow, this is really fun. And so I then turned around and took that and used that as the basis for this. So I don't know if Kat's going to be thrilled with that idea or angry at me. But big shout out and thanks to her for that. So she used Python, so that's where I started. And I love Python. Python's great, unless I'm cussing and screaming at it. So it's just Python code. But what's different about writing code in Pulumi versus writing code for, say, um, uh, you know, like a bash script, is in a bash script, it's like, okay, step one, step two, step three, you know what's going to happen. Pulumi actually does two passes, and we can see this now that it's done running. We can see this here in the output where, and let's look at this from the beginning. That's Pulumi config. Okay, so we set Pulumi up. And the first thing it did was it figured out what it had to do. So it runs your code to figure out what the model is going to look like. What's the state going to look like? What are you attempting to do? And then it does a second pass. And in fact, I think it might do more than two passes, to be honest, where then it actually does the thing. And so that makes for really interesting debugging because you can't just do print X and expect it to work. There are also, you don't necessarily know you're going to know certain values on time. So as an example, in Open Unison, we deploy the dashboard, Kubernetes dashboard. We don't know certain things when we write the code. And so what we have to do is like, I'm looking for an example in here. And we cover this in the book where you have to use what's called a lambda. I'm looking for, let's see, a cert. I'm looking for an example of a lambda. Here we go. So this is an example here where we need to have a function created for us that will give us the value in the future of something that doesn't exist yet. It's very meta. It's very Inception. This was a big mental block for me. I could not get through this. This took me a long time to make it through, but that's what you got to do. Same is true for secrets. So like we haven't deployed any secret information into Pulumi yet, which we're going to do here in a second. But this was a big mental block. Once I kind of got through this mental block, writing this code became much easier. The other thing that you need to do is you need to track dependencies, right? So like I'm deploying Open Unison, which relies on the Kubernetes dashboard. I have to tell Pulumi that, right? Because I don't have this step-by-step. I have this model. So Pulumi has to know what sequence things are going to go in. And so that becomes part of it as well. And Kat has done at least one rewrite of her initial code for cargo that this was based off of, where she like really showed off how to do that dependency management. I don't do an awesome job here. I'm not going to pretend this is great Pulumi code. In fact, for the 4th edition, I'll probably want to revisit, assuming we get to do a 4th edition, of course. But we're deployed. That took about 10 minutes. So we now have our control plane is now running. So I'm going to go ahead and make that bigger. Let's see. So we've got Vault, we've got GitLab, and we've got Harbor. So the first thing we got to do is unseal Vault. So if you remember from the Vault chapter, you'll remember that, hopefully you remember, that Vault has to be unsealed. Now, we ran a script to do this in the Vault chapters. We're going to do that again, but instead of putting the unseal keys into a file that can easily be overwritten, we're going to put it in the Pulumi config. So that way it doesn't get easily overwritten. So we have this nice little script here called unseal. Nope, wrong one. Vault, unseal. So we're going to run that. And it goes ahead, pulls out the keys, and kget pods vault. So now we're running. Now, important, you run this system and you're like me, I've got this thing running on a tower back there. I don't leave it running all the time. I shut it down, I turn it back on, whatever. If you delete the pod, right, so we're going to delete all the pods, don't run the same script again because those keys don't exist. You'll overwrite Pulumi, it'll be bad. So okay, get pods vault, right? So we have to unseal it again. There is a unseal after init.sh. You run that, and that unseals it based on the configuration in Pulumi. So if we go Pulumi config, you'll see that the vault key is secret. Show secrets. There's the information. Which also means be very careful about your Pulumi configuration because there is secret data in there, right? Okay, so we've got Vault is unsealed, and we can finish that configuration. Next, we're going to do Harbor. So we need to get Harbor's root password. We generate a root password when we generate a root password when we deploy Harbor, just random garbage. Actually, I don't remember if we do it or if Harbor does it. Let's double check here. Nope, that's the shared version. Harbor deploy. Let's see here. I don't even remember. Load CA search. Load admin secret. Okay, deploy Harbor. Create the namespace. Harbor secret. I guess it gets generated for us then, which makes sense. Which is why we need to get it now. So we wrote a script that lets you do that pretty easily. It is not rocket science, but we wanted to try and minimize the amount that you had to copy and paste out of the pages of the book. So we just get the secret out of Harbor and base64 decode it and set as a secret directly into our config. So let's go ahead and script Harbor get root password. So now we do Pulumi config, and we see we've got another secret, this root password, and we'll show secrets as long as y'all promise not to tell anybody this stuff, right? So we can see here there's this big monster Harbor password. We're never going to enter this. Like, that's the cool thing about this because everything's going to be SSO enabled. All right, this took me about an hour to run through, taking my sweet time earlier today. So I think we're okay on time. Okay, so next step is GitLab. We deployed GitLab with this. I'm going to come back here and close that tab, close that tab. I'm going to close all these tabs except for that. And we're going to do GitLab. Now, GitLab is also going to be our CI/CD system or our workflow system for builds. We replaced Tekton. We used Tekton in the first two editions of the book. Tekton's kind of lost its momentum, its inertia, and so it's a nice system. It's pretty standard, typical to other systems. Not anything typical about it that's really super different. But yeah, it's just one more thing to integrate. So we decided to go with just using the GitLab workflows this time. And so in order to do that, you need to have a runner that knows how to talk to Kubernetes and knows how to fire up pods that will do this stuff. And so we're going to log in as root. And then I'm going to come back here. And again, yeah, I got the root password. Scripts, GitLab, root password. So this is, again, this was generated by GitLab. Let's sign in. No. Don't care is a dev instance. Okay, so we're signed into GitLab and we need to create a lab bar. Now, this is going to look a little bit different than what you see in the book because this is the latest version of GitLab and they've changed a little bit of things, but nothing too crazy. So let's go ahead and we're going to go to the admin instead of admin area. And we're going to go over to CI/CD. So I'm on page 601. Now I'm on page 602. This is the most not cloud native way to do this. There was unfortunately no way to do this otherwise. So we're going to go to runners. And in the book, it says new instance runner. This says create instance runner. You can give it some tags if you want. We're going to say for everything, run untagged jobs. And that gives us a runner. Now we've got to get our, oops, they hide it down here. So we got to get the secret. And then we need to configure Pulumi. So we do Pulumi config set gitlab.runner.token secret. gitlab.runner.token. All right. And then we need to generate a personal access token. Unfortunately, GitLab, at least when I wrote the book, I don't know if that's still true. What's going on? GitHub Action. Yeah, I mean the thing with Tecton is it tried very much to be a very Kubernetes native experience, and I think what a lot of people started to realize was that it it basically ended up looking a lot like GitHub Actions. And it added a lot of complexity. Like they had started to scale down some of the complexity that they introduced, trying to be flexible, which I can understand. Assuming we do a fourth edition, I'm undecided as to whether we will go with GitLab again. We might go with Argo workflows. I really like Argo workflows, and even though it creates a lot of work without a lot of direct value to this environment, I want to show people how to do these integrations because that's really the hard part. So that's something I might think we might do. But anyway, so we need to create a personal access token in order for us to be able to interact with GitLab. So we're going to go to, I am on page 604. Oops, preferences. Yep, you leave this page. And then we're going to go to personal access tokens. It was called access tokens in previous versions. And we're going to call it Open Unison. Now, this is one thing I hate about personal access tokens is they are static. It'd be nice if GitLab supported a OIDC issuer for tokens. I don't know if they do yet. I haven't looked, but that would be nice. And we need API because we need everything. Because this is what Open Unison is going to use to do the automation. So we now have a token. Let's scroll down here. I did this. All right, so now I'm on page 607. Oh, I don't know what that is. I'm going to move that off screen. And we are going to sudo Pulumi config set gitlab.root.token secret. Right? Yep. All right, so now we have all of the secrets we need to finish our control plane rollout. So this is finishing the integration with Harbor to get SSO working with Open Unison, finishing the Vault initialization, getting SSO working, and the GitLab integration, getting the GitLab runner up and running, and doing the integration with Open Unison. So we're going to go ahead and do that. And let's do Pulumi up and dash yes. So this is going to take a few minutes. Well, that solves it for me. I've got to say, I've been looking at Argo a lot. I have a Jenkins instance that I desperately need to get rid of, that I use for a lot of my internal builds, and I really like Argo workflow. It makes a nice balance between complexity and simplicity. It's got a really nice UI. The one thing that's really weird about Argo, and I talk about this in a blog post in Trello, and I actually did a talk on this at ArgoCon last year. The the way they do SSO is kind of squirrely, because instead of using your token to talk to the API server, Argo binds your ID to a service account and then uses that service account to talk to the API server. So that gets a little squirrely, but we handle that. Yeah, no, I'm down with it. But apparently, Kat's not. Hey, Kat, thanks for coming on and hanging out. And yeah, it's not Pulumi versus Argo. We trust me. There's enough complexity here. We need both tools. Yeah. In this case, we're talking about Argo for build workloads and workflows, not infrastructure onboarding. So where are we? This is still going. Okay, so we're updating the Open Unison deployment. One of the things I did with the Open Unison code for Pulumi, which I probably need to fix, is so Open Unison uses a secret to encode for passwords for PKCS12 files, and you as the user don't really ever need it. So we just generate random garbage for it. But the problem is the way my Pulumi code is written here, it generates a new one, which means every time you update, you end up rolling out a new orchestra deployment, which is a little slow. It's a little wasteful. It'd be a little nicer if I can clean that up. Something else that's interesting about IAC and Pulumi when it comes to how you write your code is there are some assumptions you can just like gloss over when you're not using a tool like Pulumi. Like for instance, when you deploy Open Unison using impersonation, you deploy the Kubo IDC proxy. Well, when we deploy via Helm or via the OU control command, which is just 3 Helm charts in a trench coat, we don't wait for anything we don't wait for the Kubo IDC to finish and move on because we just trust that'll eventually happen. It's not that big of a deal, but you can't do that in an IAC thing because everything is sequenced. So if you're running things out of sequence, it breaks things. So we had to add an extra job that waited for Kubo IDC proxy to be running before we said, okay, this chart's done. Okay, so the control plane is done. How are we doing on time here? We got about 15 minutes. We should be okay. So last thing we got to do is we need to get SSH working. Now, if you're running this on a system that has SSH, this is when, and this is why we broke this out. This is when you need to, if you're doing the same trick I am, where it's a single node cluster and you're using host port and you're using SSH, this is where you would need to change your default SSH port to something besides 22. If you are using like MetalLB or some other internal load balancer or an external load balancer, you don't have to worry about that. We're running everything through Nginx, Ingress Nginx, including our binary protocol. So we need to patch it so that'll work with, in addition to MySQL and web, port 22. So scripts patch Nginx SSH. So we're going to go ahead and run that. Now, this is doing a Helm upgrade. Oops, here we go. So this is doing a Helm upgrade. And then we've already run this command to add port 22 as a host port. So if we take a look and get pods and ingress. Oops, no. All right, so it's pending. So my favorite way to do this is just scale it to 0. We'll let this go. Now I'm going to do the same thing. Yeah, there we go. And we're going to go ahead and scale it to 1 and wait for that to come back up. It did. Yeah. So last week at Ingress Nginx, or Ingress Nginx, see, it's on my brain. Last week at KubeCon, the venerable Ingress Nginx, well, we should have like a memorial for it, may it rest in peace, will stop being supported in March. I get why. It does make me sad. I get why. It's such a great tool. It's so versatile. It's probably not good for production. But it is such a great tool. I get it. And nothing but love for the thankless maintainers who have done an amazing job on it. Probably going to be switching my stuff over to Traffic, to be honest. But at least for now, this lab isn't changing. It'll be on Ingress Nginx, even though it's going to be as support, because this is in production. And then, yeah, I know it's unavoidable. It is, as Thanos would say, inevitable. Okay, so Nginx is back up, and let's just make sure that it works. I can do a key scan. Okay, so I'm able to talk to SSH. So our control plane from Pulumi standpoint is done. Next is we gotta go do dev and prod. Now, thankfully, those are a lot easier. So first thing I'm going to do is I'm going to switch over to my dev, and I'm going to run my upgrade of Nginx, because each dev and prod cluster is going to run their own MySQLs to support vCluster, because if the control plane MySQL goes down, you don't want that to take out all your tenants, right? So we separated it out, and then I'm going to go ahead and patch, right? And then get pods. So we have a pending. So let's scale to 0. While we're waiting for that. I'm not going to tell you which one to go to. I find that after Nginx, Traffic does seem to be the easiest to work with. I think one of the things that a lot of people are going to run into when they move off of Nginx is that Nginx reads all your secrets. So it doesn't matter where your certificate is, which is part of the problem, to be honest. And you have to do something, some funky stuff to try and lock that down. Whereas most other ingresses, in order to trust secrets and certificates and whatnot, has to be in their namespace. They have to have access to it. It's much less automagic. And so I feel like that's where people are going to get hung up the most, switching away from Ingress Nginx. And then, as Kat points out, Cilium does have a built-in gateway API support. I have found that its ingress is a little hokey when it comes to split protocols. It's been a long time since I played with it, though, so I'll have to play with it again. But I've run into issues trying to run TLS with Cilium's ingress. All right, so let's scale this back up to 1, and then we're going to go ahead and go over to prod and do the same thing. See if I can get this all done in under an hour with me blabbering the whole time. All right, control patch. Yep. All right, and this says there's no change. Oh, okay, I must have done that right. Kget pods and ingress. I'm on the right one, right? KCTX. Yeah, that's prod. Okay, good. I must have done that before I snapshotted it. Excellent. Okay. So we now have our dev and prod prepped. The last thing we need to do is tell Pulumi about it. And so I'm on page 609. I'm at the bottom. And we're going to go ahead and do, I'm going to cheat here. Pulumi config set, what is it? Kube.dev. So that's my Talos dev. Kube.dev. That's the context. Pulumi config set kube.prod. Pulumi. All right. So now Pulumi knows about our dev and prod clusters. So once more, with feeling, and this should take about 5 minutes. So this should be the last Pulumi run we have. We're going to have one more automation step when this is done. So a lot of Pulumi so the way all of these IAC tools work is they have a core API, and then they're providers, right? Well, the most popular one out there is Terraform. And so what the smart folks at Pulumi said was, okay, instead of trying to keep up with Terraform, we're going to make it easy for you to import a provider from Terraform into Pulumi using something called the Pulumi bridge. Now, it's not like a wrapper, right? Like you're not reliant upon the Terraform module. It's taking the Terraform code and converting it into something that you can use with Pulumi. And like we already have one thing broken. What's broken? What failed? Uh-oh, what failed? What failed? What failed? Error. Not successfully created. Oh, I wonder if I never get pods and open unison. Oh, that's our problem. There's our problem. I thought it was weird that that was already set. That's because I never rolled back. Let's go ahead. Let's roll back prod. Do, do, do. All right. And then since I am sure this thing's going to be really mad at me because it's like, wait a minute, it's like a week ago. We're going to do a quick reboot here. And this is the beauty of doing things in VMs with, no, I don't want to shut down. VMs that have snapshots, right? Like, what a wonderful time to be alive with all these wonderful toys. Um, so once this comes back up, I'll go ahead and fix the ingress, and then we'll run it again. We should be okay. We're just waiting for prod. I do have to say, I know it's weird, but I love watching systems initialize and print out logs. Like I don't like maybe I'm weird. Well, we know I'm weird. But like I just there's something mesmerizing about watching the data just kind of scroll by. Um, there's no there's no rhyme or reason to it, but it's something I enjoy. Yes, that's a great way to put it. It's yeah, I love it. Um, yeah, I mean, I'm yeah, we're using Calico uh, for the most of the labs. I suspect we'll probably think about switching over to Cilium in the fourth chapter or the fourth edition. I got to talk to Scott about that one. Um, but yeah, it seems to be the default. Now, I will say there's no Cilium in here. These clusters, uh, Talos by default runs with Flannel, which if anybody who's not a super well versed on networking, it's like the simplest way to run networking in Kubernetes. There's no network policies, no eBPF. It's an overlay network. Um, it's got the least capabilities, but works. Right. So out of the box, Talos is Flannel, but of course, that doesn't mean you can't run Cilium. It's just that's the way it is out of the box. All right, so we're back up and running. So let's get back to here and then kget nodes. Where am I? I'm on prod. So let's run this Helm upgrade again. Hmm. Kat, I feel bad considering you helped me basically write this entire thing off of your original code. But yeah, no, absolutely, 100%. All right. And then kube control patch. And technically this is doing for um, 22 as well, but we're not super worried about security here. So we're going to wait for controller to come down. And we will bring it back up. This is how you know it's a live stream, right? Something went wrong. If everything just worked, it could have just been a video, right? All right, let's try this again. I said before, once more with feeling. It's going to probably take about 5 minutes, so it will, unfortunately, we will be breaking the 1 hour mark. Yeah, it looks like we just did. Okay, well, Um, so this is going again. Now, one of the things that is both interesting and infuriating, and I don't really have a good way to do it better, is I actually don't like deploying Kubernetes resources with Pulumi, if I'm going to be honest. I find it to be very verbose. Um, I appreciate the ability to sequence things, which is something that is a lot harder to do in Git. Um, like my first instinct is to say, I want to, I want to generate instead of um, using Pulumi to deploy everything. I want, oh, why? What is this angry about Cert Manager? I, I, I didn't. What does this not like about Cert Manager? Oh, it probably. Wonder if it tried to run Cert Manager. Um. Ah. Um. Yeah. I mean, you can get around a lot of it. I found the balance I liked was using Helm, although that runs into its own issues. Um, the Okay, so this is we'll come back to that discussion in a second, Kat, and not to forget about that. But this is kind of one of those weird things where Kubernetes has one state, this has another, and here it's fairly easy to fix. Like if I do a kget namespace, so it's complaining that there's a cert manager namespace already. Or that there is no cert manager namespace. That's because it thinks in its last run it ran a cert manager and now it doesn't. So it's gotten itself confused. Uh, Here, I think the easiest way to get around this, let's see if we can fake it. Fake it till we make it, right? So let's try this again. So back to your point, Kat. At least in this code, I found I was doing a lot of using Pulumi to deploy Helm, so that way I could sequence the Helm charts. Um, what I think would be interesting to do is and cut down on the verbosity. I do know that you can use it. I think it's pretty close to the because it's the Go templating engine, so I'm pretty sure it's pretty close to the same functions that you have available in Helm. Um, I think it would be interesting to use use Pulumi to hydrate to deploy Argo, hydrate it, pre-initialize it, and then use Pulumi to tell Argo to do syncs rather than telling Pulumi to deploy the charts, right? I don't know if you can do that, but so as an example, oh, this is gonna be painful. I'm gonna have to run this again. This is probably the same thing where it's going to complain that the namespace isn't there. Now, this is not a reflection on Pulumi. I would say this is probably a reflection on me not spending enough time learning how to do this correctly. Um, but yeah, I would like to be able to deploy Argo. And then, like with Vault as an example, Vault I'm deploying via Helm chart. Well, I want to create a Argo repository that has the Vault home chart. But then, because I need to do things in sequence, tell Argo to do the sync. So this is going to complain about the namespace, and let's see if I can do the same Kubernetes dashboard. Okay, so hopefully third time's the charm. So Yeah, so there are certainly areas where I would like to explore being a little more separation of duties ish. Oh, you're right, Kat. I completely forgot. It shows you how long it's been since I've done this. Um, uh, yeah. Um, I forgot about refresh equals true because with refresh equals true, it's actually reading in the data to help figure out and sync versus just assuming it. But it looks like we got past that, thankfully. We are now there. Yeah, and um, it's a popular pattern. Like, how do we bootstrap Argo and then let Argo do a lot of the work? And like here, we're going to allow Argo to do a lot of the work for our tenants, but not for our infrastructure. And I don't love that. I think it would have been better to let Argo do a lot of the work for the infrastructure as well. That's how I do my production deployments for customers. Um, but yeah, I definitely think using Pulumi for more of the underlying infrastructure and for orchestration and for synchronization, the conductor, uh, but let Argo do the work of actually interacting with the API server as much as we can. I really think that that's going to be the kind of that sweet spot of working with Kubernetes. I think you're spot on there. Um, okay, so we are now rolling things out. In this case, we're rolling out Open Unison. And the nice thing about Pulumi is it can walk and chew gum at the same time, which means, oh, and now what's broken? This is really starting to what or okay. So we're going to try this again once it's done to uh, yeah, prod just seems to be having all. So we're going to rerun this with refresh to make sure that the model is getting updated because this is clearly having issues with prod. I don't want to have to rebuild this thing from scratch again. I want to try and get through the rest of this. So we'll let this finish and we'll see if we can recover with refresh. Now, the one downside to refreshes on a regular basis, it'll take longer because it's rebuilding its metadata. Yeah, I agree 100. And it's interesting because I'm totally blanking on his name, and I feel horrible about it. From AWS. Anyway, his idea was using Argo to deploy Argo because like bootstrap, and we run into this in all like infrastructure deployments. Like if you look at the way most commercial um, Kubernetes get deployed, they deploy a little Kubernetes to deploy big Kubernetes. That's how a lot of the on-prem Kubernetes get deployed. Going back to like OpenStack, you had triple O, right? OpenStack on OpenStack. They use the OpenStack deployer to run OpenStack. So it all gets quite meta. So let's try this again. Yes, thank you, Jack. All right, so let's try this. Refresh. All right, so this is what the refresh command does that Cat pointed out. And what it's doing, and this is going to take a minute, is it's rethinking through its internal state to figure out what it should be, what it is, kind of try and sync things in. So let's see if that fixes it. And this takes a little longer because it's got to go talk to everything to work out what's going on. So this is going to take a bit. So let's talk a little bit about what we have left. So once this is done, and knock on wood, this is the last run. We're going to have one last process to run where we're going to do some bootstrapping of Argo CD and um, Argo CD and GitLab from Open Unison. And the reason why we're doing it in Open Unison and not in Pulumi is because at least when I wrote this code, there was a bug in the Pulumi Terraform provider that or the Pulumi Terraform bridge provider for GitLab that wouldn't let you create groups in GitLab community. It would only work in GitLab, uh, uh, the paid version, professional version, and so that kind of broke the idea where I wanted to do all of our bootstrapping in in Pulumi. So we're going to use an Open Unison workflow to finish the bootstrapping process because Open Unison knows how to create those groups inside of GitLab and knows how to talk to the API. We're also going to initialize the GitLab repos, set up the correct identities there, get the initial namespace in there, and then we're going to initialize Argo to talk to all three of our clusters, our control plane, and then our dev and our prod. Now, we'll, at that point, technically, we could start to actually roll out tenants. We're not going to do that today because one, we're already 15 minutes over, and two, and we can see that Kat's idea seems to be working, right? Because we've gotten past the issues we were having. So thank you very much, Kat. Two, vCluster made a change from when I wrote this that broke my code. So I've got to fix that. So if you try to roll out a tenant, it won't work anyways. And three, we don't really talk a lot about Argo CD or GitLab in the book. In fact, this is the first time we talk about it. And I feel like we kind of did both products a disservice by doing that. So we're going to, in the next lab video, which will probably be the week after Thanksgiving. Next week, Thanksgiving here in the US. My nieces are coming to town, which means on Wednesday I will either be having lots of fun or hiding, depending the way the rest of the week. I've got two young nieces. I love them to death. And when they get together with my boys, it is just pandemonium, but it's the fun kind of pandemonium. And so we will probably skip next week for the Thanksgiving holiday here in the US. And then we'll be back at it. And what we'll probably do is we'll start at deploying the tenant and seeing what it all looks like, and then see how that looks like in all the different components, because we deploying, each tenant has something in Argo. They have something in Vault. They have something in GitLab. They've got to get all the groups and everything get tied together, and how all the identities all work together. And we really kind of glossed over that in the last chapter of the book. We were so focused on building something that I feel like we really did a disservice to these projects, considering, hey, there we go. So once again, thank you, Kat, for saving my skin. Okay, so, but yeah, in the fourth edition, I'm looking to break this chapter up into like 3 or 4 chapters on its own, just to explain what's going on. So, okay, so we now have, everything is running. Okay, so I'm going to go ahead and log out of GitLab. And we're going to go to katou.that. So here we go. So I'm going to log in as my M. Mosley user. Never. Go away. And of course, LastPass is going to ask you no. Okay, so here's our portal. Looks a little bit different than in the book, and that's because one of our customers did a accessibility review, and we implemented happily their recommendations. So you can see we've got Vault, right? And we can SSO into Vault. That just works. Yay! We got GitLab, and we can SSO into GitLab. Yay! We got Argo, SSO right into Argo. And then finally, we have Harbor and SSO work. So we've got all of our components integrated from an identity standpoint. So the last thing we need to do is, well, there's two things we need to do. First off, you'll see that we've got our developer control plane, but I don't have access to dev or prod. So we're going to fix that first. I'm going to go into request access. And I'm going to go into Kubernetes administration. And this is on page 611. Now I'm going to shortcut this a bit. Bootstrap, since I'm also the approver, or I'm going to do a pre-approval. And then I'm going to do the same thing here. Bootstrap, request for someone else. Mosley, approved. So I'm going to submit that request. Let's go look up my user and check them out. And we can see here, okay, cool. So it's been provisioned, dev, and production. So cool. All right, so I'm going to log out, log back in. So now I'll have that, and we can see that I've got my control plane. There's a dashboard. I could do kube control as well. And then here's dev. And here's prod. So I now have access to all of my clusters. So we've got one more workflow to run because we need to get Argo bootstrap. There's nothing here, right? If I go to clusters, I've got in cluster. That's it. We need to change that. So the first thing we need to do is I'm going to come back here. Oh, you know what? I want to go over here. Export kube config control plane, kget pods and open unison, klogs f, and open unison f, unison orchestra. There we go. All right, so I want to tail the log so we can see what's going on here. So I'm going to go to internal management workflows. And we're going to initialize open unison, check out bootstrap. Now this one doesn't have an approval process, so I'm going to just go ahead and submit it. And away we go. So what we're doing here is we are provisioning Git repo into GitLab. We are pushing templates into GitLab. Right, so Open Unison can provision directly into an API server. It can also provision to Git, so that's nice with the same workflows. And you'll see these Get targets. We'll talk about this when we do our deep dive in Argo. Argo has to talk to these remote clusters. Thou shalt not use service accounts outside of your cluster. So this is the magic we're doing with token exchange. We'll talk about that in our next show. Or in one of our next shows, I guess. So we go ahead and we provision everything, and then we come back here to Argo, and hey, look, we got 3 apps, but unknown, right? That is because Argo doesn't trust our SSH repo. We got to get SSH keys. So this is our last manual step, and then we're done. So Argo login, or Argo CD login. This is the easiest way I find to do it. And I'm on bottom of page 612. So popped open a browser. And I will say much love to the Argo project for finally adding Pixie support into Argo CD's OIDC flow. So, okay, I'm logged into Argo, and then we're going to go do SSH key scan, and we're going to add that. Successfully created 3 SSH entries. So now, come back here. No. Here we go. So we can see here that these are unknown. Now, Argo CD will eventually refresh itself. I don't really feel like sitting here and waiting for that to happen. So there we go. Eee. And that's it. We're synced. All of our bases are bootstrapped. We've got 3 clusters now set up, ready to go. And they're all integrated. And so now as we onboard our tenants into this multi-tenant platform, what we will be able to do is create tenants in Git rather than directly into API server. So that way we have GitOps, right? Thank you very much for bearing with me. Again, thank you, Kat, for dropping me that hint on Pulumi Refresh, and of course for helping me learn Pulumi in the first place. The infrastructure's up. Feel free to give this a try at home, and then we will see you after Thanksgiving for part 2. Probably going to be deploying a tenant, and then we'll work backwards from there. So if you're in the US, happy Thanksgiving. If you are not in the US, have a great week, and we'll see you in a couple. And thanks everybody for stopping by.